So in this video, what I want to do is to ask you to have a go at this integral. This integral is, I think, harder than any of the others that I've put into this series of integrals so far, but have a go at it and a detailed solution will follow. And the integral comes from the MIT Integration B final of 2006, and if you just put into Google MIT Integration B 2006, you will find a video of people attempting integrals like this and harder. So let's have a go at it now. And then if you come back after you've thought about it, I'll give you an answer. Okay, welcome back. Let's look at the answer. So here's the integral that we want to calculate. There is this factor of x to the minus a half here, and the denominator is 1 plus x to the 1/3. And you could try a substitution, say your new variable is x to the 1/3, and then you could also say or your new variable is 1 plus x to the 1/3 and see what happens. I'm not convinced they're going to work very easily. And the next thought I had was to say, well, let's say that this is 1 plus a tangent squared. Because if you say that 1 plus x to the 1/3 is going to be 1 plus tangent squared theta, well, that can be simplified using trigonometric relationships to sec squared theta. And then you basically just have to hope that the numerator will somehow play ball and that everything will become nice. So let's have a go at it. So x to the 1/3 is tan squared theta. That's what we're saying. That means that x is the cube of this, so it's tan to the 6th of theta. Therefore, the derivative dx d theta is, from the chain rule, bring the 6 in front, 6 tan to the 5th, reduce the power by 1, and then multiply by the derivative of the thing to the power, that's the derivative of tangent, you get sec squared. So that's dx d theta. The equation we're using is if you have an integral of x, some function of x with respect to x, you can rewrite x in terms of a new variable, just as we're doing here, insert by hand dx d theta, and integrate with respect to theta. So here's our integrand. Let's rewrite this with using this relationship here. So 1 plus x to the 1/3 is sec squared theta, that we've said already. X to the 1/2 would be tan cubed theta. X to the minus 1/2 is 1 over tan cubed theta, and we write that very easily as the cotangent cubed. And then we have to insert by hand 6 tan to the 5th theta sec squared theta like this. We see something lovely immediately. The sec squareds cancel. The 6 here can be just pulled outside of the integral, so it doesn't do any damage sitting out there. And then we've got cot cubed times tan to the 5th, and that's tan squared. And as soon as we see this, we feel extremely happy. Tan squared we can rewrite as sec squared minus 1. That's our favourite identity whenever you see things like tan squared. Sec squared integrates to tangent, minus 1 integrates to minus theta. Now, what is tangent of theta? Well, it's x to the 1/6, taking the 6th root of here. What is theta? Well, if x to the 1/6 is the tangent of theta, theta is the arctangent of x to the 1/6. So this is our result. 6 is on the outside, multiplying x to the 1/6 minus arctangent of x to the 1/6, and that's the answer. And on the next slide, I will differentiate it to check that it works. And why don't you have a go at doing that before you look at the next slide? Just practice differentiating this, and the more you do that, the better you will get at calculus. Okay, let's have a look at the next slide. I assume you've had a go at differentiating. Okay, here we go. We're going to differentiate our result, and we're going to see that we get the original integrand. So the 6th can be pulled outside the derivative, it's irrelevant. The derivative of x to the 1/6 is 1/6 x to the minus 5/6. That will cancel with that in a moment. We're also going to get a 1/6 from differentiating this, so this 6 is going to go, that's clear. So that's the first term. Then we have minus. The arctangent, the derivative of that is 1 over 1 plus the argument of the arctangent squared, which is x to the 1/6 squared, multiplied by the derivative of the argument of the arctangent. So on the next line, we have, I'm just going to get rid of the 6 because it's going to cancel with the 1/6 in both terms. We have x to the minus 5/6 from here, minus 1 over, when you square that, we get 1 plus x to the 1/3. Hooray, this is what we wanted. Times the derivative of this is x to the minus 5/6. Looks a bit messy, but x to the minus 5/6 is a common factor. Let's pull it outside and see what happens. So we're left with 1 minus 1 over 1 plus x to the 1/3, and that we put on a common denominator of 1 plus x to the 1/3. This is 1, so we have 1 plus x to the 1/3 over 1 plus x to the 1/3, and then we've got minus, put it back, minus 1 over 1 plus x to the 1/3, and so you see that the 1's here and here cancel, and we are left with a factor of x to the 1/3. X to the 1/3 times x to the minus 5/6 is best sorted out by putting these both into sixths. So it's x to the 2/6 minus times x to the minus 5/6. So that from the rules for powers is x to the minus 3/6, which is x to the minus 1/2, and the denominator is what we wanted. So we're extremely happy. This is the correct answer. And I take my hat off to all the people who go to the front of the board in that lecture theatre to take on the test.